Hello, I'm Fred Cohen, Director of the Webster CyberLab. Along with me for part of the presentation today are Garrett G. and Charles Preston. They are CyberLab managers. And this is the first lab, the intro to the CyberLab lab, which anybody that's going to use the CyberLab should probably do as a matter of course, and maybe at the beginning of each semester just to get ready. The CyberLab is designed for doing science, the science of cybersecurity. As such, we're trying to create systems and mechanisms in which we can do experiments with causality, testability, refutation, and adaptation. The basis of science, and cybersecurity science, of course, as a subset of science, is that cause works via mechanisms to produce effects. That's written as C greater or arrow M E. Cause acts through mechanisms to produce effects, and causality is foundational to all of science. In order to be a scientific theory, it has to be testable by experiment, among other things. And the experiment has to be able to show the theory is wrong. Otherwise, it's not a scientific theory. And for a universal theory, we can never prove anything right. And the reason is that we don't get to do every possible experiment forever that could possibly affect it. What we do instead is we test the theory by trying to refute it. And if the theory is refuted, we'll try another one. But in order to test, we need to measure something. And the question is what and how do we do that measurement? And that's what the CyberLab is about. It's a place to do measurements and tests. And just to give some context, the flat Earth was a scientific theory. At some point, an experiment proved it wrong. I believe it was called circumnavigation of the globe. So science developed a new theory and moved on. The CyberLab is for science. So science requires that we isolate the phenomenon under study, which means we need to try to minimize confounding factors, make it repeatable to within defined bounds and be able to define the bounds of repeatability, make it consistently measurable, regardless of the person doing the measurement, as long as they're competent in the relevant areas of science. And then, of course, we use simplification because we might be able to do lots of work on a beam, but trying to do scientific experiments on buildings means that we would have to, for example, see all the different ways a building breaks, whereas seeing the ways a beam within the building can break is something that's maybe more tenable. So instead of trying to boil the ocean, we try to separate the problem into parts and solve the parts and then try and figure out how to fuse those parts together to create a larger working environment. Engineering is more complicated than science. It applies scientific results in a much more complex world and seeks to get some sort of design rules and calculation methods so that it can engineer things that, bridges that don't fall down and computers that don't crash, at least not very often. We need the science to do the engineering, but ultimately we're going to need the engineering for the real world. The CyberLab is about the science. Now, the CyberLab has a bunch of parts, and I'm not going to detail it. There's a better description in another briefing. But I'm just going to give you a quick overview of what happens and how it works, then I'll show you as an intro to the lab. So what's in the lab, the co-location CyberLab is for systems and network security experiments. There's at least one other CyberLab today, and there will likely be more over time. There are several physical computers isolated from the internet. Each one supports several virtual machines, VMs. Virtual machines, or VMs, are accessed via VNC over SSH. VNC is Virtual Network Console. And what that means is you're acting as if you're on the console of the computer and logged in as root. So you have complete control over the machine that or machines that you're operating. And Secure Shell, SSH, is Secure Shell. That's an end-to-end encrypted or something like that. The point being that, in effect, there's a secure path between you and the console of that computer to the desktop that you're using to access it. And we'll see how that works as well. From each VM, each virtual machine, the user has or creates sub-VMs. So each sub-VM, each VM within the VM that the user has complete operational control of, is accessed via VNC to its console. So the VNC goes into the virtual machine and allows you then to create more virtual machines internally that themselves use VNC to provide interfaces to the console as root to those machines from within the VNC console to the outer machine. Sub-VMs are networked, typically to each other, and they can access an FTP server. They don't retain state past reboot unless and except as you allow them to mount floppy disks. You can create a virtual floppy disk and mount it and store things on it and retrieve things from it. But that only retains state for the rest of the VM session. The VMs that you're running in, where you're super user on console, they run in time slots as well, and they reboot and they don't remember their state. So the only way to remember state across sessions is when you store the files in the FTP server, and the FTP server is supportive of all of the students in all of the virtual machines within each CyberLab facility. The environments run a version, the VMs run a version of Ubuntu Linux, and you'll see it in a few minutes. They're platforms for controlling your experiments. You shouldn't be doing the experiments on the VMs, but rather within the submachines within those VMs, because, among other things, if you screw up your VM, it's not going to reboot until the next time you have a time slot. And you don't have that many time slots to finish a lab. They're really the platform controlling the experiments. The sub-VMs, they're largely running white glove Linux. White glove is a specialized 15-year-old version of Linux. It has no hard disk storage, but it could have if you wanted it to. It boots from a CD-ROM, which is stored as a file on the VM. It takes startup commands from a floppy, which is also a file on the VM. It has a small, fairly efficient version of X11 and a graphical interface. You'll see that. It has networking, web server, and so forth, all built in. It's small, lightweight, and so forth. So you can run about 10 instances of the white glove virtual machine as sub-VMs within your outer VM with reasonable performance and without running out of memory or disk. So how do you use this? You know, the VMs have the what's called Virt Manager for a graphical support of QEMU, which is the emulator that runs the sub-VMs. White glove runs in the QEMU sub-VM manager. So you start Virt Manager, start the virtual machines, do your experiments. But in order to do the experiments that are later in the courses you take, you really need to spend some time understanding this environment, getting used to it, and so forth. So you need to learn that by doing it, and that's why we have Lab1. Hence Lab1. I'm going to put up a pretty picture, and I'm going to take you over to the VNC that I'm using. It's called a program called Chicken of the VNC. It's running on OS X, which is a Mac operating environment. Garrett will show you how this works from a different VNC interface on a Windows PC, and Charles will show you a different one running under Mac. Following the instructions that the access layer gave me, and you can read about the access layer online. If you go to all.net under courses and webinars, you can see the Webster CyberLab and Cyber Explorers. And you can see there's access, Webster CyberLab access. So following the instructions of CyberLab access, we were given the information necessary to set this up. So we set this up, and I decided to use VNC. So I'm following the instructions, localhost 5903, and you provide a password. That's a password that works for your time slot only. And I'm going to just push connect, and you can see I'm connected to some remote system. And so what happens next is you can see my cursor moving around there. The screen will typically go dark just from screensaver, and then as you move around, it'll notice besides the little circle, there's also the arrow. The arrow is the mouse on the remote machine. The circle is my mouse here, and you see they can vary from each other. In order to run the virtual network manager, you run Virt Manager. So I'll just run it here. It pops up in a GUI, and you can see again, because the mouse delays, there's a delay between my mouse here and that hand, which is the remote mouse. See? I'm just going to slide this over into the corner for the moment. And I'm going to start one of the sub-virtual machines. In this case, it's a Lab1, White Glove Linux System 1. So I'm just going to push go on that. I'll start the second one. You can see the graph here shows virtual machine CPU usage. If you want to see the console of the machine, I believe you click here, and it shows that machine to you, and you can see that one booting up. And I'll switch over to this machine, and I'll show that one booting up, which will come in a separate window. Oops, I think I just changed the ordering, but nothing else. There we go. There it is. I'm going to resort by name. There we go. So you can see these virtual machines are booting up with white glove Linux, and it takes a minute or two for them to boot up. In the meanwhile, in the external machine, I can do other things, like I can run an X clock to see what time and date it says. It says it's 7:21 a.m. Pacific Daylight Time, wherever that particular machine is. And as these machines boot up, I can take from the console and order them to do things. Now, I just clicked in the console, and note up here, it says press home to release the pointer. I can't use anything else anywhere else because I've clicked in here. I'm now essentially stuck in this machine, but I'm going to push the home button, and now I can move outside of the machine and go to other places. So it's just important. If it says press home, you have to remember press home to get out. So I'm just going to log in as root here. There's no password. And I'm going to start X11, which is the graphical interface. And if one of these doesn't work, you just try the next one. And I'm going to push home to get out of there, and I'm going to come up here. And I'm going to, you've noticed home sometimes produces some extra characters. And I'm going to start X11 over here. And I'm going to push home to get out of here, and I'm going to come over here. And so I now have these two virtual machines. Whoops, that's too slow. I'm not hitting home there. There's home. So I'm in this VM, and you notice in here that there's a different cursor. See this cursor here? That's a cursor for that virtual machine. You should also notice that you don't see it right now. And the reason you don't see it right now is because this virtual machine is running an X11 window that's a big X11 window. See, so I'm going to come over here and expand that window so you can see more of what the window is. And you can see these scroll bars over here at the edge. So I have most of the window in here, but not quite all of it. See that? I'm just going to click to let go. See, it's a little bit confusing from time to time. There we go. So now I'm inside that window, and you can see the arrow and the ball. The ball is where my physical cursor is in the outer machine, but the arrow is where the cursor is within the computer. So I have to go into a window in order to use it. If I go out of the window and type, it won't work. Oh, well, I guess it left it there that time. I'm going to right-click to get a menu, and I'm going to do something like bring up a, now the mouse is hard to manage sometimes, but you've got to work your way through it. That's just how it is with delays and virtual machines. I'm starting up a web browser now on that particular virtual machine. I'm going to hit the home button and just move this out of the way. The web browser eventually will start. There's another machine, the other virtual machine over here, and you notice the delays. So you got to be careful. If you don't wait it out, you can run into trouble by not knowing what you're doing. There's the cursor for this machine, again offset. And I'm just going to go DHCPCD, which is get myself an IP address. ifconfig. Tab to complete, and there it is. I have an IP address, whatever it is. It's 192.168.122.252, as you can see. Right there. Okay. And by now, we hope, I have to get home to get out of here, get over to the other one. And it'll take a second to refresh, and you can see there's a web browser now running in there, and you can get, for example, again, remembering that the cursor is that other arrow. Click on the help card. And this is a help card that's built into the CD-ROM that runs that version of Linux. So that's how that works. I'm just going to close the interfaces to these machines. Note, when you close the interface, you don't necessarily turn off the machine. And you can just bring the interface back later as and if you want. Again, it takes a second sometimes. The interface is gone. And you can see we're still here. They're still running. They're not doing very much, but they're running. And I'm just going to shut these down. I'm going to force this one to turn off. It asks, are you sure? Yeah, I'm sure. I want it to shut off. And I'm going to shut down the second one. Force that one off. Now, just again, at the end of your time frame, your slot, this machine will be restarted in an initial state. So you won't see any of whatever was there before. Whatever you did before goes away. Same with each of these machines. When you shut them down, they don't remember anything. So that's how that system and mechanism works. I'm now going to hand it over to other lab managers to show you different ways of access and how those things work. And okay, Charles Preston is sitting on his Mac, and he's going to start a different VNC session simultaneously with mine. And as he's doing this, I'm going to be doing some other work. Charles, take it away. Tell everybody what you're doing.
This is VNC Viewer from Real VNC. It's one of the viewers that you can choose to run on a Mac or on other machines. It already has the localhost 5903 entered from a previous session, so it's there ready to connect again. If I say connect, the normal message I see from this viewer says that it won't be encrypted, but since it's already in an encrypted tunnel, I don't care in this particular case. And then I have to enter the password. And that's your cursor instead of line moving.
Well, I see you've joined me. So let's just try something while we're here, Charles. So I'm going to start trying to do calculations, and you go into some other window and do something else at the same time.
Okay. I'll go into this window, see if I can bring up something else on white cloth.
So you see the problem that's happening here is that I'm trying to compete with Charles over the cursor, and every time I move, he moves. Every time he moves, I move, and while we're doing that, things just don't get done because and we each have our own cursors as well, but we're trying to control the same background cursor, and that's where the problem lies. Oh, I almost got a click in there. Got it. Hey, got an answer. I won. So clearly, if you're doing a cooperative lab, this is potentially problematic, Charles. Has that been your experience? Well, we're having some voice problems with Charles. In the meanwhile, so we have two people in this session, and I'm just going to hand the control over to, or display over to Garrett, and we'll wait for him to come up online, and we'll Charles and I will continue to wrangle over the cursor in the meanwhile. So Garrett is about to join us in the session, and we flipped the console over to Garrett's. What operating system are you running, and what tools are you using, and tell us what happens next, Garrett.
Sure. So, hey everyone, this is Garrett. I'm on a Windows 7 based machine. I have two utilities that I'll be using to connect into the CyberLab. One is PuTTY, and the other is VNC Viewer from Real VNC. Both of them are free open source applications. From a PuTTY SSH perspective, the thing that you want to configure for your tunnel, your SSH tunnel, based upon the instructions, is this setting in the connections SSH tunnels area, and you can see that I have a few of them set up, but in particular for the user that I'll be connecting to, it's on 5903, so that's that setting for the SSH client. And since I'm already logged in, I will connect into utilizing the Real VNC Viewer application, once again to 5903, and I will connect through there, and then now I'm in the same windowing application shared VNC session with Fred and Charles, all trying to compete for this magical cursor.
So I'm moving the cursor at some point, and Garrett can move his. And it's fairly interesting because Garrett has a green background while I have a blue background in the same sub-virtual machine running White Glove. Of course, I'm going to defeat them all here. That's too soon. I'm trying to get out of there. Did I get you out? I got you out. Okay, so we're all out of that VM now. Oh, you clicked us back in. Oh, now we're in trouble. All right, so in any case, you get this sense that you can use this. We now have 3 users in a collaborative laboratory, all in the same console, the same virtual machine. So if you're doing a lab as a group, you can come in from different locations and work together as a group, recognizing things like different color screens. If you all come in this way, then you can just use a telephone call to talk to each other. Or another thing we do is sometimes we'll do it this way. And just note that, of course, without an editor or something here, everything you type is a command. So another version is you could, just have a window with an editor up and everybody types independently in that way. There's a variety of ways to do things with chat. So Garrett, or whoever set open chat window, show us how. Okay. Eventually.
I'm not actually sure how to do that, Fred. I remember there was a program. I don't remember what it was.
Yeah, of course, the problem with chat is we're all going to be chatting in the same space with the same methodology. So we can share this window, but we really can't get a lot of work done without having some voice as well. It's just hard to communicate this all by text. You'd probably end up doing things like and so forth. So it's not as fluent. No, thank you, Charles. How helpful. So it's better if you have a voice going on in the background so you can talk, and then one or another of you can take over a function. And if you know how to do something somebody else doesn't know how to do, they can do it. And also, very often you want to look things up. So I'm going to just take back the meeting. And you should all be able to see my screen now again. So when you take back the meeting, one person might be doing some work on the machine, trying to get something to function, while I'm sitting here looking up something like I might go for this lab, for the #1 lab. Go look up Linux intro and find that the common utility of grep does something. And then try and do that command in this window, and then the next person can do their command in this window. So in any case, this gives you a sense. You can do collaboration on these remote machines, multiple users using the same facility, and with voice and other things going on at the same time. You can get the labs done. And once you learn to work in this environment, you may never want to go back. What do you guys think? I just want to make sure that we have an understanding of how you run the lab. The lab assignment is, in essence, to work your way through the Linux introduction, which talks about booting up from a CD and what it looks like and how it works and how you use menus and how you type commands and so forth. Okay, these are all things. They may not all work on this particular version of White Glove. This talks about Linux system structures, users groups, files, directories, programs, and processes, and how they work, about protection bits and how they work. And it gives examples of some things that we want to do in the CyberLab, but not at home. Some of them will cause the virtual machines to crash. And when they crash, you can just use that interface right here to stop them and restart them. And so you'll want to do that on a regular basis, probably. But it gives you sets of commands and shows you how they work and talks to you how everything operates. So that's the intro to Linux. And then you might want to go through Linux networking. Linux networking is definitely a bit different in the laboratory environment because you don't have actual internet access. You should read through and review and understand how all these things work, and do these as part of your lab. And if you don't have enough time in the CyberLab to do this, you can, of course, run this on another version of Linux. You can get the CD. You don't need to order it by buying it. You can just get it, and there's an open source copy available. Walks through common network tools and how they work, network servers, building up Linux networks. We will, over time, have more than one computer on the network, virtual machines. Those two virtual machines can talk to each other. And in fact, most of the experiments in the lab, Lab2, which is the distributed denial of service example, for example, has 8 or 9 machines, virtual machines running at the same time. And then you might also want to walk through Linux firewalls to understand how you set up firewalls, how firewall works, and so forth in this Linux environment. So that's your assignment, is to go through. You go to all.net under Courses and Webinars, and you click on Linux Intro, Networking, and Firewalls. You should also review the Webster CyberLab and Cyber Explorer videos. And that's your assignment. So if you have any questions, I'll be happy to take them.